a research methods course, and I would love to if I had time. But I like doing the data collection in class because it lets us deal with research methods classes too. Number one, why did I make you guys test each appendage 3 times each? So we're going to throw out the high and low and take the median. So right now, circle your 2 medians, because that's what we're going to use for data. Find the middle value. So when Elizabeth said, crap, I missed it by whatever, 3 seconds or whatever it was, that's okay. We're going to throw that one out. And then we're not going to use the average, we're going to use the median, because if something happened and you had a goofy outlier, an average would be affected by that outlier. So we're going to go with the median data point. Does that make sense? Keep that in mind if you have to do this in your fields. Keep that in mind. Why did I have you flip the coin? And why was that important? Thank you, Ben. Why was it important to randomize the first appendage? This might not be obvious, but give it a shot.
Well, I guess it could eliminate the possibility for fatigue. Like
Yes! Oh, I wasn't thinking fatigue!
We should have alternated between finger and thumb so that, because you perfected as you repeat it.
That's why you alternate. You either alternate or randomize. The idea, remember the energy bracelet data I described? I'm going to find this for you. I promise I will find it for you. It might not be the end of this term. I'll email it to you later. The problem was they got the guy to do a standing long jump once, then put a bracelet on him and said jump again. So he practiced, right? He had a jump under his belt, so therefore he knew what the jump felt like. The second time, he's automatically, unless he didn't learn anything from the first, gonna do it better. Same thing with your finger and thumb. If I have you randomize though, whatever learning takes place is hopefully then distributed across the 2 appendages and is noisy enough to cancel out any bias in the learning. That might not be obvious, and it might not even be applicable, but it can't hurt to do. Whenever you can, randomize anything you can in a trial. It makes the most sense. Fair? Okay, good. Now, what I'm going to do is, I'm going to turn the TI on, and I'm going to go around the room, and we can collect this together. Whoever had a stopwatch that worked for all trials, I'm going to come get your data. Ben, did you say finger in L1, thumb in L2? Sure. It doesn't matter, does it? It doesn't matter at all, does it? Let's go finger and thumb. So I'm going to come around and get each of your guys' data. I'm going to put it in the L1 and L2. So Ben, did you have numbers for me?
Yeah, L1 is 22.91, and L2 would be 23.03.
1-3, thank you, sir.
03.
03, gotcha. Gotcha. So we're going to go finger, thumb. Let me write that up here so I don't forget.
None of these values match anywhere.
So 2303. Beautiful. Who got next data? Brian, you got data for me? Go ahead.
Yeah, I got 22.72 for L1 and 22.81.
Beautiful. Thank you, sir. Tyler, you got numbers? Should I turn this down so you guys can see it better? Go ahead, Tyler.
22.95 and 22.87.
Excellent. Thank you, sir. Gabe, you got some?
No, my last one.
Totally fine, bro. Totally fine. Not a problem. Erica?
22.65
Thank you.
and 23.07.
2307. Thank you. Chris, you got some?
22.69
Uh-huh.
and 22.68.
Uh-huh. So, hence your claim. There's no difference. Right, good, good. So again, it's anecdote because you're based on a sample size of 1. Yeah. But then you test it, right? You go get more data and see if it holds. Thank you, thank you. Casey, you got some?
No.
No, that's okay. Anna, did you get some that worked?
No, I don't have a.
Oh, you guys didn't get stopwatches. Totally fine, it's okay. Elizabeth, you got some?
22.90
90.
and 22.96.
0.96, thank you. Very nice. Aaron, you didn't have it. Rory, you didn't get it, did you?
No.
It did work. Okay, that's fine. Chris?
I couldn't get the.
That's okay. Trace, you got some?
22.85.
She's professional.
Yeah,
She is.
She's got it.
She did it in her head.
22.85. I got 22.85.
22.85 for both of Thank you.
Persistent.
Thank you. It's very good. It's very good. And Jake?
22.78
Uh-huh.
and 22.81.
8-1. Thank you guys for data. Good. It almost all fits on one screen. Did everybody get a chance to put it? Is it okay where it is right now? Hopefully you guys got a chance to write it all in, because I want to make sure you guys can crunch the numbers too. Good. Good. So Chris again has his, I mean, why would you think there's a difference? I mean, and honestly, it's not like you're asking us to do a specialized skill with a thumb versus a finger. Like write, or like hold a spoon, you know? Like there's something very simplistic about pushing a button. Why would a thumb or a finger be different? Which is why Doug was so consternated. He's like, oh my God, this is ridiculous. Well, let's test it and see if there is. If there is a difference, we'll inspect it. So let's put the differences in L3, yes? It doesn't matter to me if you go L1, L2, L2, L1. Doesn't matter at all, right? Let's just go L1 minus L2. So if they're negative, that means the finger was faster than the thumb. Make sure you understand why. If they're negative, if we do L1 minus L2, that means finger minus thumb is negative. That means thumb is bigger than finger. Bigger means more time. More time means slower. That was a lot of steps. Did that make sense? That didn't make sense. Okay, so negative 0.12. There's a difference there, right? Which one has to be bigger if this is negative? This one has to be bigger because we did this one minus that one. Smaller minus bigger equals negative. Bigger is a measure of time. More time. More time means slower. Jake?
Instead of going higher or lower, don't we want to go more accurate?
Well, we're trying to see that with the difference. All I'm trying to do is explain why it's negative. Negative and positive can both show inaccuracy, right? They're off 0. 0, except for Tracy, who got 0, right? Except for Tracy, who got 0, there's always going to be a level of offness, whether it's negative or positive. So yes, at the end of the day, we're testing what you just said, 100%. But I want to make sure why you guys, why negative versus positive are different. One means the thumb is faster. How about we just say this? One means the thumb's faster, one means the finger's faster. How's that? And you can see how they flop around. We got a negative, a positive, a negative, a positive, a negative, a 0. We got it all over the board.
Rather than accuracy, I thought we were just testing to see if there's a difference.
That's what Jake's saying. All I'm trying to say is, I'm trying to explain why, I'm going to stop trying to explain. I'm making it worse by trying to be helpful. I apologize. I apologize.
With the
Damn
exception
Italian.
of Tracy, who does this, like,
Yes.
professionally.
Yes.
Everybody, all the different parents are gonna be different because each time you do the race, it's gonna be different.
That's why we're matching the pairs. You see, yes, every single one of the parents. Suppose one of the parents is always 5 seconds off. There's a delay in their brain. The kid touches the wall. Boop. That's okay, but as long as they're consistent with that, if you do a matched pair, the difference is removed. And all you're looking at is how their thumb differs from their finger. It doesn't matter that Jed is different than Jesse. What matters is how are these different on Jed. Jesse is irrelevant. Does that make sense, Chris? Jed might be an outlier when viewed at all the parents, but viewed to himself, as long as he's consistent with how he's measuring, that doesn't matter. Does that make sense?
Right, so why wouldn't you explain that to the parents?
I don't know. Ask Tracy.
If they use the finger all the time, or they use the thumb all
Well,
the time.
because let's see if there's a difference and we should even say it. Please, Gabe.
What are those last values in L1 and L2? I didn't get those.
Oh, no problem. Let me scroll down. It looks like it's 22.78 and 22.81. You guys are taking this further than I wanted to, which is good. I'm glad. But all I'm doing is I'm giving you the tool to measure the claim that Chris made. I don't think there's a difference. That's all. That's all. Good. Good for you. Good for you. Good for all of you. And thank you, Tracy, for the insight. I appreciate that, too. Cool so far? I'm going to take a quick look at it. Oops, turn my plots off. That's right. There they are. Okay, I'm going to make the window a little bit better. Was it 180? Actually, 180 wasn't bad. I kind of like that. I'll jack this up, though. Okay. 0 difference. It's not perfectly symmetric. The curve shifted a little bit to the left. We also have a sample size of 7. So it's a little bit noisy, which means the margin's going to be huge. Low power. That's okay. So we've got an interesting outlier. We do have an outlier that might be jacking the average around. There was a big difference. Big by statistical comparative standards, right? See that outlier down there? So do we throw that out or do we keep it? Well, maybe we keep it, run the test, and see if the outlier is the only thing affecting the results. How about that? If the outlier is affecting the results, we might want to retest it without the outlier and then go find that parent and figure out what happened. Maybe it was a watch problem.
With only 7, you can't throw it out.
You can if it's hold that thought, Chris, hold that thought, okay? Hold that thought. Hold that thought. Let's run the test. Let's finish off this hypothesis test. T-test. Everything's going to be exactly the same as it was before, except for the fact that we're testing it two-tailed. So you gotta change that sign to does not equal. Because remember, we ran this, we set up our hypotheses before we had our data. Chris's hypothesis is no difference. I say there is, let's see who's right. Who's more likely right, I should say, not who's right, who's more likely right. Who the data supports, even better said. Fair? Let's run it. All right, here she comes. Oh crap, hang on. Turn my graphs off. Okay, you guys are already getting it done. Now it's called a two-tailed test. You're about to see why. There's the two tails. Because what it does is, it creates a test statistic of negative 1.472. 1.472. 1.5 standard deviations. Notice how it's negative? It's just down here. That means technically, whatever was in L1 is smaller on average than what was in L2, because it's negative, right? That's what we said, negative meant smaller minus bigger. So finger was in L1. So the fingers are a little bit faster than the thumbs, which was also implied by the histogram being shifted a little bit left. But, go ahead, Trace.
I just thought that was interesting.
It is kind of interesting. It's also very noisy because of our small sample. But let's come back to that if you don't mind. You see how it's shaded on this side too? The reason a two-tailed test exists, and I'll have a quiz for this for next week for you if you want to look into it. It lets the researcher be super sure of a null hypothesis rejection, i.e. a small p-value. Because it says, you see how it flipped off down here this time? Randomness says it could have just as easily been on this side. And it calculates both p-values essentially and adds them together. So each one of those tails is about 9%. Combined, they're about 18.5%. Regardless of whether it was a one-tailed or a two-tailed test, what's the p-value?
18%.
Which is big or small? It's big regardless. Which means
There's no significant.
it doesn't appear there's a difference. Chris, you were right, at least according to our little sample data set. It does not appear there's any difference between a type 1, or between a thumb and a finger stopwatch time. Could we be wrong?
Yep.
Always.
What if we use this finger?
What Sir, as an East Coaster, I appreciate that. Fair? Type 2, possibility, right? Now, I want to do one more thing. This is not to affect the quiz you're working on right now. I want to take that outlier out. I want to pop that outlier out of the data set and rerun the tests. Because I want you to see what's going to happen to the p-value if you remove that outlier. It's fun that we got one. I wasn't expecting one. I wasn't looking at the size of the differences, just the differences themselves. So if I go into the data, it's this guy right here, that negative 0.42. Fun. Bye-bye. So here's the new histogram. Turn them off again. Here's your new histogram and dot plot. Okay. Notice, smooth out a little bit. There's no outlier anymore. Histogram, it's not going to look very good because we have so few data points. It's not going to have a nice mound shape, but it's hard to argue that looks pretty bell-shaped to me with a sample size of 6. I can't really argue with it all that much. Then I run my tests. Okay, watch this. Hang on a second, turn these off. Thank you. Old dog, one trick, can't remember it. Watch, watch those tails. You see how they shifted in a little bit? The difference isn't as extreme anymore because that outlier was pulling the average. Now, it's not a huge extreme difference. It went from, what, 18 to 28. So you added 10 more %. But it did affect it, right? The bigger these tails get, the less the difference is. I've run this test in classes when almost the entire curve is shaded because the thumb and fingers are so close. And when they're really close, there's no difference, which means you're... Remember what this curve is. This is the curve of there is no difference. If there was a difference, there'd be some other curve over here or over here. You're shading an awful lot of this there is no difference curve, right? If you're shading an awful lot of there is no difference, that means you believe there is no difference. If you're not shading it, that means you're shading some other curve, which means there is a difference. And so this goes back about 4 weeks. I'm going back in the past a little bit here with the breast cancer and green tea and all that stuff. So when you see a lot of area, that means you agree with the curve that's sitting in front of you. And again, it all goes back to what's a lot of area? More than 5% for us in class. Fair? Want to turn that one in for an in-class? Sure, why not, right? Good. I'll make a two-tailed quiz for you guys for next week, just because this isn't the most obvious thing to talk about, a two-tailed test. Not the most obvious thing, but I do want to chit-chat with you about it. If you want to. You also can ignore it. That's totally fine, too. What else? Oh, speaking of next week, I only see you once. I'm very sad by that, but you also have Thanksgiving with your family, hopefully, or with friends, and that's awesome, too. I pushed the project that was originally due today back to next week because I felt like an idiot. I don't know why I pushed it back in retrospect, but I felt like an idiot because confusing him. I was talking about it in class.
I thought part of it was because of the snow day.
Oh, that wasn't my intent. That wasn't my intent. But because they're standalones, I put the due date on Tuesday, but it's not due on Tuesday. The last moment you can turn it is 8:15 on Thanksgiving morning. Does that make sense? But I figured if I put it on Thanksgiving morning schedule, you wouldn't see it. So I put it on Tuesday, but realize you have 48 hours basically past that to get it done if you see it that day. Does that make sense? So that wasn't too confusing. Cool? All right, let's make a pile of in-class quizzes, for sure.
So you told your friend there's no difference between them?
Yes, because every single term we never get a difference. And we've done this well, we've essentially done it so many times now I have hundreds of data points supporting that there is no difference, as Chris said. What amazes me is that the parents actually think there was. Awesome.
But they'd have to assume every single parent has one test. Every single parent has the finger test, or every single parent has. There's probably a difference in every parent, but it's a different finger.
Exactly. That's the thing, right? But then the thing is you have to then normalize, or I think, Tracy teaching me this today was fun though. Oh yeah, this is great. These are the ones that were goofy in Blackboard, so that's the in-class. Thank you. Yes. The conclusion.
Yeah.
No, I got you, and that's what they have to understand. This is what life is full of.
Yeah, it's a weird way.
Yes. Yes.
What would you do?
So, is your p-value big or small? It's small. It's very small. It's way less than 5%, right? Good. It's just 5%. Did yours come in below? It did. It did. That means you can't believe this,
we only have one data.
and you have to believe that.
35 data points. You put all 35 in there.
Because it's less than.
It's the opposite of this. This was a big p-value. That means we have to believe that. And in words, that says there's no difference in the thumb and the finger. No difference, i.e. they're the same. This is that there is a difference, they're not the same. But we can't believe that. Because we got a very, very big p-value. It was shaded along this curve. Fair? Now the opposite happened in your quiz. On your quiz, you see where you landed? You landed way up here, a little tiny bit of area. You think there's another curve over here. Now that curve would does that make sense? That means that you believe, not that the dilated version was not enough, that it was enough. Because you now believe that claim. You're off. This curve is that claim. This new curve is this claim. So the diluted does produce enough antibodies. It is enough.
Okay.
That cool?
Yeah.
Good. You're getting it. You're getting it. It takes a couple weeks once you first do your first one for it to really sink in.
Exactly.
Don't worry about it. Just keep doing it with me.
Well, and I was going over, all the ones that we've done in the class, but again, it's just
But just stick with me. Keep with me all through next week and the week after, and we'll get this. I promise you.
No.
Cool?
Okay, yeah, that helps.
Awesome. You got it, Linda. You got it. This is perfect. Makes me happy. Like it. Oh wait, I'm gonna. Oh, you got it. You got it. Type 1 error. It is still a type 1 because of small p-value.
Right.
Yeah, but just realize that's because you think it's on another curve. And that curve it is enough. Remember, this curve, the alternate curves always go with the alternate hypothesis. The null curve goes with the null hypothesis.
Okay.
And that's every single test we run. Every single one. Cool? You got this. Just stick with me. You got this.
It's getting
It is getting there. I got 2 more weeks. I promise you it won't go anywhere except getting there even more. Chris, what's up?
I just want to say, have you ever looked at, or I'm sure you've heard of, Rate My Professors?
Yes, I've heard of it.
Every term before I register for my classes.
Do you really?
Even someone I've never had. And this term when I was going on,
Uh-huh.
the CNCC page, it shows you who the most rated teacher.
Oh, I have.
You were the most rated teacher in all of CNCC.
Oh, most rated, like the most number of ratings going in.
And you had
How I know that? Okay.
1.9 out of 5.
Yeah.
Take it, I got you.
Actually, I was on, yeah, the other day, one of my other teachers said
Don't go anywhere.
he wanted to do it, so.
Oh, really? Yeah, I just
Yeah.
wanted to share the information with him. I was like, he has a
Yeah, 'cause
4.9 out of 5 and most
there were
ratings out of
some-
everybody.
Yeah, there were some that had fives.
Oh, there were a couple
So
that had
some
5s,
help,
but most of the
really.
ones that were 5 ones don't do votes, it seemed like.
Well,
Well, I didn't look at all of them.
And then there was
but-
like health teachers.
Yeah, that's true. Well, they're all probably. I don't know.
I mean, exercise science teachers.
That's what I was originally.
I pulled data from Rate Box Addresses for your project for next week.
Oh,
But
really?
I never looked at what they were, I just pulled the numbers, did the
I feel like if I was you guys. Oh, I'm popular? Do you kids like me?
Well, now, I'm thinking about it.
All their teachers is like that.
I know.